All right, we're going to look now at how to do calculations with significant figures. And before we start, we should address some confusion as to what these are actually called, because sometimes you'll hear them called significant figures, sometimes significant digits, and then to make it even more confusing, sometimes they can be shortened to sig figs or sig digs. It's all the same thing. So significant figures, significant digits, sig figs, sig digs, all talking about the same thing. And the idea is this, is that when you take a measurement, there are certain numbers within that measurement that you know for certain, but there's always one number, the number right at the end, that you're estimating, that you don't know its value for sure, you're just taking a very educated guess at it. And significant figures are a way of dealing with the fact that there's always part of a measurement that we're not sure about. And so what we have to do is we have to be able to take the numbers in any measurement, and we have to tell what numbers in there are significant figures, which ones were measured within the context of actually taking a tool and measuring that value. So here I've got just some random numbers for you, and we're going to look at counting how many significant figures each one of these numbers has. Now we have these 5 rules, and I'm not going to insult your intelligence by reading them to you, but we have these 5 rules that tell us whether or not a number or a digit within a number is going to be significant. And I recommend that if you want, you can pause the video and record those down. The wonders of modern technology, I'm not going to stop and read these out to you. You can read those for yourself. All right, so let's take this first number, 1.072. Our first rule tells us that all non-zero numbers are significant. So the 1 is significant, the 7 is significant, the 2 is significant. Now this zeros are always the problem when you're looking at significant figures, but rule 2 tells us that zeros that are between significant figures are themselves significant. So this 0 is sandwiched between a 1 that's significant and a 7 that's significant. So it is a significant figure as well. So this number right here has 4 sig figs. And this is all we're doing for this first part, is just identifying how many significant figures each one of these has. So we can look at this one. The 6, the 8, and the 2 are non-zero numbers. They're significant. But now we have these zeros. And if we look through the rules, we find that zeros all the way to the left are not significant. So that 0, and that 0 don't count as significant figures. And what it boils down to is basically those zeros are just there to tell you where the decimal point should be. Any zeros you have that hold no other function other than to tell you where the decimal point is supposed to be, never going to be significant. So in this case, this number has 3 significant figures. Now let's look at this one, 300. We have these numbers that are all the way to the right, but notice that these zeros right here, all they're doing is they're telling us where the decimal point should be. It should be right there. So the zeros make the difference between 330 and 300, if you will. So since those zeros are just placeholders, they're at the end of the number and they're to the right of the decimal point, they don't count as significant. So again, this is because of rule 4, if you want to point to a certain one. All right, or excuse me, rule 5, my bad. But numbers all the way at the end that are just holding up the decimal place are not significant. So this is 1 sig fig. And again, that's rule 5, not rule 4, my bad. Zeros at the end of the number and to the left of the decimal point are not significant. All right, now let's look at this one. This is where rule 4 comes into play, my bad. Here we have the decimal point, so it seems like all these zeros are doing is holding up the decimal point, if you will. They're telling us where it should be. But then we have this extra 0 after the decimal point. That tells us that when this measurement was taken, the person actually measured this value, and that number in the 10th place, was actually 0. Otherwise, there would be no reason to put that 0 there. So if you see a 0 after the decimal point, so again, rule 4, zeros at the end of the number and to the right of the decimal point, they are significant. That means that 0 is significant, and that 3 is significant, and now these fall in between two significant figures. And so this would have 4 significant figures. So now we know how to count these. We can just use these rules and apply those rules, and we can count them. The next thing we're going to look at is how to do math with these, how to add and subtract using these significant figures, and multiply and divide for that matter. But first, let's look at the addition and subtraction rules. So I have here 3 addition and subtraction problems, and the rules are the same for both of them, so you don't have to think too hard about this. But if we look at these 3 numbers, 4.7832, 1.234, and 2.02, we can figure out what digits within those are significant figures. And what we're interested in addition and subtraction problems, is the significant figure that's all the way to the right. So we're interested in this one, and this one. And what we want to do is we want to look at what place those are in. And by place, I mean this is the 10th, 100th, thousandths, 10,000th place. So there. Here, it's in the thousandths place. And here, it's in the hundredths place. Now what we want to do is we want to look at which one of these is the closest to the decimal point, which one is what we call least precise. So this one is very precise. We're measuring to a very small number. This one is slightly less precise, and this is the least precise. We're only measuring out to the hundredths place. So what we want to do is we want to take our answer and round it so that it matches the least precise. That is the one with the number that's going to be farthest to the left if we look at all of this. So this one here is 2 places from the decimal point. This is 3, so this one is closer to the left, if you get what I'm saying. Now, here's the way this works. We just take all of these and we add them, just like you would expect to. So take a handy-dandy calculator and see if I can maybe maneuver that where you can see. And you're just going to punch all this in and add it together. 4 plus 2.02, and you'll get an answer. And so I'll take my answer of 8.0372, and I want to now round this so that it matches the least precise of these 3 numbers. So in this case, that's the 0.01, rounding to the hundredth place. So I'm going to round this off at that place right there. And so my answer actually becomes 8.0, and I'm going to round this 3 up because of that 7 next to it. So our actual answer to this math problem would be 8.04. We're discarding the 7 and the 2 because those have more precision than we actually measured. That's part of what these significant figures tell us. All right, let's look at the next one. 4.7832 plus 1.234 minus 2. So we want to look at the place values of the last significant figure on here. And here we've got tens, hundreds, thousands, 10,000ths, thousandths, and then the ones place. So the least precise, the one that tells us the least numbers after the decimal point, is this. It's only to the ones place. So we want to round our answer to the ones place. So we bumped my papers. So we punch this into our trusty handy-dandy calculator. And again, notice nothing's different at the start. I would just do this like it's any old math problem. Minus 2. And my answer is 4.0172. But now I'm going to round that to match the precision of the least precise number. So I'm just rounding this off to this place, and it's going to become 4. So my answer to this problem is 4. That seems really weird to have all this long decimal place, but we can't trust any of those numbers past there because we've got this one number in here that just goes to the ones place. So our answer can only go to the ones place. Now let's look at this one. Same number here, but now this one, we have to look at the significant figure that is most to the right, and that is this one. So this one is only good out to the tens place. So when we have our answer, we have to round that answer actually to the tens place. So again, we add them up just like we would normally do. And the answer is, well, let me just put it up here for you, 26.0172. But remember, I'm going to round this to the tens place. So this would actually round up to be 30. And that's as good an answer as I can give because of the significant figures on this. So again, the rules for addition, you look for the least precise number, the number with the least number of places past the decimal point, and you round your answer to match that precision. All right. The good news is that that's actually the harder of the two major operations we do in math. So addition and subtraction both operate by that rule. Multiplication and division operate by a different set of rules. So for multiplication and division, what you have to do is count how many significant figures each one has. So this one has 5 significant figures. This one has 2 significant figures. We round our answer so that it has the same number of significant figures as whichever has the least. So we go back to our handy dandy calculator, and just as before, we're just going to punch this in just like we would normally do, and we get this answer. 2.87 blah 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 times 1.6 is 4.59568. Goodness me, lots of digits after that. But remember, this had 5 significant figures and this had 2 significant figures. We want to round off this answer so that it only has 2 significant figures. And we start that from the left part of the number, and we just count significant figures until we get to 2. So there's 1, 2. So we're rounding off after here. So our actual answer to this problem should be 4.6. We're going to round it so that it has 2 significant figures. And the rule is as easy as that. Let's take a look at this one. 2.8723 times 20. So if we just punch this in to a calculator, we get an answer of 57.446. However, when we count sig figs, this has 5, this has 1, and so our answer can only have 1 significant figure. So we start from this end of the number, we get to our first one, and we're going to round off after that. So our answer to this problem is just 60. Notice this seems a little weird, and it seems like your math teacher will shudder every time you do this, but this is math when we're actually taking physical measurements. We can't be more precise than our least precise measurement. This measurement only has 1 significant figure. Our answer can only have 1 significant figure. And those are kind of the rules for the road. You'll be using these throughout the rest of this class. Now, you'll only be tested directly on them for this objective. But every time you do a math problem in this class from here on out, it has to follow these rules. So those are the significant figure rules. Practice up and let me know if you need any help.